Aremu, the chairman of the rapporteur for this session, in person of Dr. Ode, the HOD of Surveying and Geoinformatics Department, Federal University of the best University of Technology. Defense. I've been talking about defense this morning. The first private university of technology in Nigeria, or is in Africa. Let's welcome Dr. Ode, EO. Please come and take your seat here. It's your turn now. Okay, to support him on the high table, even though our final session presenters they have the luxury of time, but because we don't have time again, the time is fast spent, so we need to have a time paper that we moderate them. We know there are lecturers that are talking and they would like to talk and talk to infinity, but we will not allow it to go to infinity, so we try to control it. So we'd like to invite to support our chairman of the high table. The person is right there looking at the Surveyor, Adesoun, to be the time giver on the high table. Please, they said it's not the proper thing for the NC to be saying, let's give a round of applause. You have to perform.
Papers before us to be presented, and I want to believe that we have them already in PowerPoint slides. We may not take the order which we have here, but take the order in which the papers are ready and are available for presentation. So in case you are supposed to present a paper this afternoon, one or two important information you need to know is you have 5 minutes for the presentation, and then we will have 5 minutes to react to their presentation. I've gone through the abstract, and there are very, very interesting topics which I believe we will learn from. We will also be able to interrogate what you have researched, what you have found, so we can build on that knowledge. So without much ado, we have in the first session a topic. It's on our topic 27, comparative assessment of automatic level and DGPS for scope analysis of major roads within the University of Lagos. And then we have 29, establishment and least square adjustment of local genetic control network using GNSS at Bells University of Technology. So if you have your paper ready, presenters presented by Abuduganiyu, Bello ID, Atta AB, and Suleiman AB. Whoever is presenting this work can maybe step forward here for your presentation. Do we have the PowerPoint slide ready? Thank you very much. Good afternoon, everyone. Good afternoon, everyone. Without actually taking our time on trying to establish a new protocol, let's proceed into the presentation of
they have comparative assessment of automatic level and differential GPS for slope analysis of major roads within the University of Lagos. If you observe very well, even without observation, University of Lagos is very close to the Lagoon Front. And most of the time, when there is a slight inundation, a slight rainfall, you find almost everywhere at the University of Lagos water. And we are having a major problem in this area. In fact, for some of you who must have gone through this route to get here, you came here earlier today, you will have seen that there was everything water on the way there. It's been a major challenge. So we are trying to, because we understood the fact that University of Lagos mostly is on marshy land and the rest of them. We definitely have to find solution to whatever problem that it is. So what we are attempting to do here is, okay, can we use GPS, differential GPS, and get a very good result? Or can we further use automatic level to see whether this will be better? Realizing the fact that the entire University of Lagos is almost on the place of this. So we try therefore to compare what results we are going to have between differential GPS and automatic level on major routes within the University of Lagos. The major routes so considered are what you see on your screen. We consider the route starting from the main University of Lagos gate. This pointer is not showing it very well. Down to Senate House and down to the Lagoon Front. And we also consider the alternative from Faculty of Education coming through Faculty of Education to DLI, and then from DLI we come to Medical Center Junction. And that road that starts from Adebhemhin Junction, we took it down to the highlights area. Then you can see the other one there, which is the access road. Sorry, I don't know how this. Okay. Then we have this access road. This access road is the one that starts from police station area and then pass through FSS and come to GNI. Now, if you have observed carefully, when you drive during every small lane, you are going to experience some water in some of these areas. So we want to find out, okay, whether in solving problems with the University of Lagos, which one would be more appropriate, considering the terrain of the University of Lagos. Now, if you check our methodology, definitely we use the differential GPS method separately. We conducted our survey first using the differential GPS, then we embarked again on using the automatic level to check the height of these major roads. We consider this interval at every 25 meters. We try to use 25 meters so that we will have enough data. Maybe, please, permit me to move close to this because I don't have it. I cannot see what we have there. So, when we checked the two of them, here we have the station that we used initially, our initial station that has been established. This was what we used. We tried to observe on them and to find what error or what accuracy we like. We checked also the vertical closure and we find out that from our equipment they are very, very good accuracy. Here is the method that we followed in getting the assignment done. Here is the aspect of the GNSS. Here is the aspect of automatic level. Now, here is our result. If you check our result here from the main gate, that road that comes from main gate down to Senate House. If you check the two of them between automatic level and GNSS, we have this variance 0.74 rather on automatic level and 1.3 in GNSS. And when we check our we check this result using our ANOVA, we have this result that you can find here. And this result shows us that our p-value is in 0.957. So we also did similarly for all the other roads which we have mentioned. And we presented their results one after the other. Now here is the graphical display of each of them, their performance. Here from main gate to the Senate House, you can see the GNSS values in red and the automatic level in something like blue. And you can see the variations in their performance from the performance of the elevation from the main gate down to it. If you check properly well, you will be, except if there is any form of exaggeration. Okay, it's 5 minutes. Okay, I can answer. Thank you very much. If you get to the medical center to second gate, here is the result. Then we try to get the flow analysis of the road based on our result. And this is what we have for, this is the result for GPS. This is the result for automatic level. They are essentially the same, except for the fact that one is better than the other. If you check the flow direction, they actually show the actual direction of water flow. And here is an attempt to show the elevation along the road. The way we found it, you see this one from Major Road, from Jubilee Main Gate down to Senate House, and from Senate House down to Pirates. So here we attempt to display it in a 3D for us to see the slope as observed along the major roads. And here is you are going to see that the road that starts from main gate to Senate House appear to be on a higher ground, others are on a lower ground. And this spot, this pointer is not showing very well. This spot appears to be the lowest from our findings. This spot which I'm touching is actually the spot behind us here. And that is where you always find water almost every time. Once there is small rain, you see that place with heavy water. So I remember I had been challenged when we made a defense with the university management to say, okay, if you say this is the problem behind engineering, why can't you look for a way to solve it? This actually served as the basis for further studies, because we are undertaking further studies on what is the configuration of this area and what is the best approach for us to solve it. So in conclusion, we said that the automatic level data points and the GNSS, they performed relatively not bad, but the automatic level, as we all agree, we actually prepare. And so we are recommending that if we want to solve any problem in the University of Lagos, we should allow DGPS to stay back and let automatic level handle the work more approach. I think that's
Thank you very much, sir, for a well-researched and technically done paper there. Would allow us to ask questions and then make contributions to this book. I believe that they have done this work, and your input will make it better. Your questions, your clarifications will also make it better.
But the working issue, for instance, it depends on the accuracy required. There are some work that the accuracy of GPS will be enough. You will not now want to go through the fatigue and boldness of the other method. I thought that the accuracy or limit to which each instrument can work, so that we know when to use when and when not to use, when it will not be a problem. For instance, if I want to solve problem of flood, where I will not need too much slope for that flood to be solved. Unlike this place now, you need big slope to solve the problem in this area. And that's why I'm investing in want to spend money. Many of us have been giving that assignment, we are giving the investing report, yet because they don't want to spend the money that they take to, because to solve the problem then we need a very slopey trench. It's going to be like a project. We're investing just looking for a minor, easy flow of water that was and something. So I expect that maybe part of the work will also have at what accuracy? Is it 1 millimeter slope? Is it 2 millimeter slope? That it will be necessary to adopt a level rather than the differential difference.
Now, we're using automatic level and differential difference for level calculation or to get the slope of flow of water. I just want to ask what, because when you look at differential level, you know, that one work on geometric, the height of that one is ellipsoidal height, which is a little bit different from what the automatic level will give. Now, in considering your data when you are collecting from site, don't you think that the data you're getting is not a little bit different from each other? Because when you are considering the distance you have gone, at least it's more than 1 kilometer when I look at it. It's more than 1 kilometer. What is the different height? Or for you to consider differential GPS to do your flow, the slope of water from one point to the other, to make sure that what you are doing is correct.
No, your question is not yes. Are you talking about, there are two reference heights?
Yes.
Are you talking about the reference height?
Yes.
Okay, because you are question that
because when you consider the geometric heights,
is it or is it
automatic heights, yes. Which of the two levels are you using so that you can get your results?
HOD is quite aware of the efforts that have been going on about flood behind here. And it's going to be interesting to know that even this point that we have here is even lower than Lagoon front. What we are trying to do in the current research we are doing now is to get a bathymetry of some aspect of the Lagoon front and experiment if we should have a drain from here to that place, whether there will be a backflow. Because that is the major problem that if you have a drain from here to that place, whether there will be a backflow. So that when we think we are able to solve a problem, we are now not creating bigger problems. So our current research is attempting to take that not only getting the height around here alone, but getting bathymetric data of the Lagos Lagoon, maybe to as far as that Formula Bridge, and have a kind of global view of what it can be, because before we can take a global solution to the problem. Now, like the HOD already mentioned, this problem has been to the VC about 2-3 occasions. So I think it's also aware of me. In fact, we provide about 3 of them, 3 solutions. None of them, before we finish with the solution, we have a new building behind them. And that new building diverted all of the water that was going there, and that diverted it again to the road. So we have to start all over again because nobody was thinking about that building there before. So I think that is that about that. Now on the height we are using, definitely for GPS we consider soil and automatic we consider autometric. We just decided to do it separately to know if you do any of them, which one can we just continue to do. That's what we do. Thank you very much.
Thank you very much. And having said that, I think, like Professor Ogunsola said, it would be nice to add to the work the limits of accuracy to talk about, just to include in the work, so you know that between, for DGPS, this is the accuracy, and then for the digital level, this is also the accuracy, just to make your readers understand at a glance.
Thank you very much. Thank you very much.
I've heard that in Unilag, you don't need to stimulate people to clap before they clap. So I really have found that. Thank you very, very much. Now, we move to the next paper, which is titled Establishment and Least Work Adjustment of a Local Genetic Control Network using GNSS and Data Fusion at Bells University of Technology in Qatar. The presenters can move forward. The paper is authored by Adebohemhin A.S., Samlami T.J. Alabi A.O. Nawati Ogunjimi M. Aketu S.O. Adekola R. So we have the presenter already. He will have 5 minutes for the presentation of the panelists for the Thank you, sir. My attention is just being drawn to the first 2 papers. They're actually supposed to be plenary session paper, which means we have more time to elaborate and to educate us. So please, not to constrain you so much of time, even though we are working behind them, we will allow you to do justice to it within 10 minutes, 10 to 15 minutes.
Good afternoon to everyone. I stand here to embrace the system people. I will not continue to stand for the rest of the day. So I don't stand as the system people. I'm here embrace it. I'm here presenting a paper on the establishment and this that came in the morning made us to realize we need geospatial data to do a lot of national development, to control so much about erosion, to ensure that the buildings we are placing on an environment is standing in an area you can easily identify that there will be no trouble or problem coming up with it in the near or far future. So we are looking at the issue of establishing local geodetic network in Malta, because in the best university we discovered that there are no much of control stations that can easily be used to do some engineering infrastructural development. So why do we need to densify the environment with controls? One of such is that it's a backbone to geospatial work. It's as well a backbone to establishment of infrastructures, construction of works, either roads or buildings in any community. Now, the legacy control that we have in that place as of moment is very inconsistent. So because of that, we want to have a network of control that are very dependable. Now, the hybrid adjustment is underused. The issue of using DNSS and total station together, I think for knowledge sake, some of the students have not been exposed to this. So the objective for this research is to establish just some control points. We choose about 9 of them, which are second order pillar, according to Surv 2003 specification. We want to derive a 3D coordinate via this adjustment. So we're looking at X, Y, Z of the various points that we are chosen. And we truly want to assess the accuracy of the point that we are trying to establish. And at the same time, using some statistical analysis to analyze our data. We actually want to compare adjusted coordinates to those ones that are already existing there, so as to know whether there's any very wide standard deviation or disparity. So the study area is the best request and total. Now the existing control that we tell about to is always above. But to ensure that we have independent control system that is being established, we try to work to the courses of Unilab. I can't remember whether we use other courses, but I'm very sure that of Unilab, so that we have a minimal error, which is our major reason why we are bringing up the work. So the methods involved development is we went around to look at what are the areas we can establish these controls so as to support the ongoing development in the university. So we pick up such areas, we do documentation, and we start carrying out the field observation using DNSS and a total station. So we process the data, and from there we integrate at least going to our to adjust the work. So we have accuracy assessment where we discover that we need we use a least square method where we have we wanted to use a higher one, but for the sake of the knowledge of the students that are involved, so we limited ourselves to making use of observation equation method. So in our data acquisition, we stayed on the station, I think for about 2 hours, making the static and mode observation. So using triple R10 to have a frequency for the static PPO. Now, after these 2 hours, that will take initial station, simultaneous adjacent station occupation. Now, we, as I said earlier, we connected with the bus station, the Unilag here. So using later Infinite 4.0 for a fixed UTM31, EGML, EGML 08. Now for our total station at 11, we observed of phase left, phase right. We have wanted to make use of maybe using about 8 rounds or 4 rounds, but the time frame that we're having was limited. Would have been able to have a better accuracy than what we have here. So we only use phase left, phase right. We did not go on either 2 or 3 or 4 or 5 phase rounds. So distance corrected, we corrected it for diffraction, for conversion, and for conversion. The bandage, body shape, redistribution adjustment was used to correct our angles and distances. Now, for the list adjustment, we did not really go into much about what will have applied in classroom because the frame of the time that we have was limited. So I wanted some of the students that were involved to use both observation equation, condition equation, and at the same time to use mixed model. But the time constraint did not allow us. So only based on one of the method in order to adjust. Now, in our adjustment, we assumed that our weight was an equal weight. At the same time, considering the kind of development that we want to use this observation for. So we looked at it that for the data that we have confidence of about 95% on, it is reliable and very useful to carry out any infrastructural construction that is engineering. So if it is maybe a multi-story building that is very complex, we have been looking for a higher confidence on the data that we are trying to collect. So that would have made us use maybe a 99% confidence on the data, but just limited to that one. We discovered that the centering errors and the high error were just 1 mm and 2 mm, which is really the confine of what is required in engineering construction. So, in our result, we labeling of the pillars, the point where we made our controls, S05, S06, down to S15. So we discovered that in our S13, 6 and 7 and 13, we have some wider disparity in the height issue. And that was 7 also. It's giving us the issue that is a very wide standard deviation. So we're trying to look for some of what will cause a dip. Looking at our SD, that is standard deviation range, from 0.3 down to 11.0. That of 11, we also that will be the range of 9, 8, 9, 10, 11. We really don't consider them the form we did a very good accurate observation. So we went back to the field. We discovered that we are still retaining almost the same data. So we allow them to stay. Now we do some comparison, looking at a maximum height, which is 12.3
we still fall within the range of second order war. Now, when we have our biggest concern is what happened here. The legacy control that we have in that environment, we're having, comparing what was on ground with what we have, we discovered that we're having 141.4 meters. Now, we've been trying to search for what could have brought this issue, what could have brought us such a disparity in the data that we collected. Now, we discovered that this could be attributed to that tooling consistency that was used for the existing control in that environment. Although the particular discrepancy was not all that much, it's what within the range of 0.006 down to 2.29 meters. So the vertical one was a bit better, but the horizontal one, it was very, very obvious that the disparity, the standard deviation was was far apart. So the plan agreement that we had when we started our work was between 0.001 down to 0.005 meter across the 9 stations. So the least collection we were able to have under our collection, under our list we have this range of refinement and the taking analysis through F-test and the T-test. These are the things that we're able to have. Now looking at our p-value, which is we have our for T 1.29 for the listings, we have 1.10, and at the critical value we have 2.306. So the P is greater than.
Time is up. We can just quickly wrap our hands.
Okay. So in our conclusion for that work, a precise modern local control network is now in place at BUT, that's the University of Technology, which is a second order control. Now comparing what was existing with what we have now. What we have now is more reliable than what was existing in that place. So we plan to diversify that environment, diversify more controls, so that if it is possible, what was on ground before, eventually we continue with it. So in reliable reference for engineering survey, cadastral monitoring and GIS in the campus, we already have it for planning purpose. And our recommendation that longer GNSS station at the obstructed stations for added redundancy, we need it. So rigorous pre-survey instrument calibration is needed, and precise learning to supplement our GNSS height. We also predict that we suggest that one. So in dedicated data transformation, we want to look at that so that the people look at that so that we could have a more refined result at the end of the day, which the entire environment will depend on for engineering, construction in the near and far future. Thank you very much for listening.
Thank you very, very much for the paper presented. We will now take questions and reactions. I will maybe start by asking what that session was used for, but you take all the questions and answer all at once. Any other question? Yes.
I have these 2 or 3 questions. One, you talked about that home inconsistency that maybe that was responsible for the 114 meters water bill. So, and I was wondering that should we not have established the consistency of the control we use, because we work from both parts, and we should have used set of controls that are within the same framework to do our work. So I'm wondering if that could be the problem and how that problem was addressed. Then I was also looking forward to seeing the order of the control that was established. Say second order control network, say third order control network, given that that is what the area here now will now rely upon, because this order need to be classified and the accuracy achievable, one is to 50,000 or one is to 20,000. So these are the few maybe concerns that I have. Thank you very much. The chairman is the one that has the question.
Sorry, mine is also confusion because I know, I'm very aware that we did have one course session. So I'm actually practicing school. So I know that the state works with UTM 21, while Lagos State works with Vector 4. So my main question is, which platform is Unilag course working with? Is it working with Vector 4 or UTM 21? Because if we are actually working with, because BELS is in the states. So if you are working, you are establishing control in the states. Why not use the state course? I want to use the state course instead of coming to instead of time with Unilag. Thank you.
I just want to know, so far, Genesis and Obasanjo and Paul is the reference for the GSS used. What is now the takeoff point for the Obasanjo is in the research?
Thank you very much for all the questions. Mr. Chairman, you asked why we use a radio station. We do a comparison because the work is a bit beyond this. So we compare the leveling height, the heighting that we have for the radio station, compare with the leveling, and we saw that the site was very small. So for what Dr. Adeyemi asked, now the 141 point something meters, it's not really coming from our own work. So it's coming from what was on ground before. We tried to compare our own work with what was on ground before. We discovered that the disparity from what we had was very far from, it was very wide compared to what was on ground initially. So looking at where these people are coming from, what they tied their work, to, it wasn't on course. And we don't understand the basis of some of what they use, maybe when they brought their control from. So that was what made us look at. No, they control here, if we continue to defend on it, that are they not going to put the entire authority to problem? So that made us going to establishing more controls. Like you rightly said that Ogun State, I think if you wash out Lagos or whatever, you are still on zone 31 altogether. So, yes, we are still on zone 31. We are still on zone 31 together. So, if there is a call here, a call in Ogun State, a cause in Abuduganiyu or in a place like the saying, and you can access it to make use of anyone on there. So the one we have access to, like the one in Ogun State, I'm very new to Ogun State, so I don't know of any call station in Ogun State. So the one I have access to, that's what we use of to do our work. Yes, so Salami, your question is me.
Control station used for total station.
Okay. I think I showed it there. The control that made use of Batoto station, it was shown on it's one of the stations within the base. Now what we did was to observe on that station,
connect what you have, we connect that station with our course here. Now, it was the very first station we were concerned on to ensure that we defined coordinate values, which I think about 2-3 days. No, after then, we look at what we have, that these values are dependent, because have the make use of our tutu station connected with that point. So from that point, we connect all that points in the research work.
Thank you very much.
The chairman.
Okay. Do we have reactions from reactions? Okay.
I have one reaction to what he said. Yeah, thank you very much, Chairman. My reaction is not to the presenter, but to the question to our surveyor from the state. Because I see the point he raised as a fundamental problem in the surveying profession if we don't guide the state. Now, Oswald is talking about having a geocentric Adesoun for us so that we're operating on a unified control system. Now, if we say Lagos is on vector 4, Lagos and Ogun, the share boundary, Ogun is on other framework. So, are we not going to cause problem? Are we not going back to the era of the local control systems as NLO? Before you now know it, you now have this survey everywhere, of which if somebody who has worked in Ogun State, another person has worked in Lagos State, the two of them cannot even connect together. For example, you know, there is this diagram that we use to teach, whereby somebody is coming with road construction doing from this end, and that person is coming from this end, and the two of them that are supposed to connect, they are not aligned. So that's not the type of problem we now create in the future. Even within this Lagos State that we are seeing vector 4, what I mean, if tomorrow Oslo completes this geocentric so are we going to now begin to readjust and now go back to the problem of ordinary transformation? So I want us to take it back to our various chapters and let it be what subject of discussion. So before the thing will escalate and become out of control. That's the reaction I have to the position. Thank you.
You look at the team of this conference, and then of this, we want to have sustainable development. And if care is not looking just like what you said, well, sustainable development also rests on those decades that we have here and there. And if care is not taken, then many things can as well happen. So, taking it back, one. Number two, because it's a research and it's a very also an institution, and then the researchers also will have it there. You can as well perform more experiments. I will call it experiment, that is carry out more studies. I know Surveyor also has a course station in Korea, aside the one in Lagos. And there are also other courses that can as well get to from around Lagos here. Otis Arts, and some of them also are Chica Arts, and something like that. Let's specify something. Here on campus, we also have something like that. If not of recent, all our control points, you have differences in one thing or the other. But for sustainable development, what we are saying is not for now. Sustainability means take care of what is happening now, and while we are also taking care of our future. The future should not be what we faced before. And that's why the nation is also not here. Because this is also part of the score work where we are doing the data transformation and so on and all like that. So, for sustainability, we need to take it further than just living in the way we say. If somebody is saying that they are using another thing, here in Lagos, then what are we saying? NIS, where are they? So, it's something that's supposed to be looked at. If, following what the Bible said, if Oswald is going along that line, then all the states something also should follow.
in such a way that all these errors will not be. The Adebohemhin there is also from Ogunsola. They know what they are facing about what we are talking about here. This guy that wants to come and do PhD that didn't later come for his defense, this is what he said he wants to address in his work also. So please, for sustainability, we need how to solve this and put it to relate. Thank you.
In fact, I have an information.
Okay. But before the information, can we? Yes, sir.
Thank you, Mr. Chairman. I need to be corrected if I'm wrong. I'm in the industry, I'm a person surveyor. Are we saying that the gradation in the use of calls and instruments and whether you are doing a perform or whether brings a change in the coordinate system and the value of the coordinate? My answer is no. All these instruments, all call stations and all GNSS equipment, they have a defined value. I don't see any disparity. I think what happens or what will make the difference when we are talking about the is in the presentation, not in the coordinate value. Because I don't see you having a coordinate value, using whatever you use, and somebody using another call station, in Lagos, having a different coordinate value. Let's look at that. So to me, it doesn't really key in that it's having different coordinate values based on the various instruments. Otherwise, it gives everybody using different instruments, getting different values. It's the presentation. But of course, what you are going to present. It's like somebody in a state, still producing their plan in NMO, and another person producing in UTM. Are you with me? The coordinate will not necessarily be different for in terms of the origin. That's my position, and I stand to be corrected. Thank you.
Okay, thank you very much. The information I have, thank you for the recognition of the chairman. We are carrying out one research presently. I want to tell us authoritatively that even within the Lagos state we are talking about, we are having issues. Sacregion, NIS course, and two other courses also that the OTs and another one that we use. We have up to 0.4, 0.5 differences in the coordinate given from this. In fact, I wanted such to be presented in this words. I told the student if unable to present it in this type of this thing, we will find a way also to present it to. Well, I will say that there's a problem. So, the problem, sir, just as you said that we expect that we should have the same thing. The different equipment manufacturers that are producing this course, they are using different parameters. Don't forget, we are also loading global this model now into which the damage our automatic pipe. So if we have different parameters that are not unified, we will have different coordinates, we have different results. So what we are trying to do now is to link those core stations, their observation, including that of the NIS portal, with that of Oslo, which started the course establishment in Nigeria. Let's see how they are doing. Because it is going. If I tie my work to Otis course, another person ties his work to Sacregion, another person ties to NIS, all of us will not have the same result. So which coordinate are we going to rely upon? So before we know it, if we chart our records, we will be seeing overlaps and the shift here and there. And the vector 4 is because of a different parameter. That's why we have 20. So we cannot afford to go back to the problem of the past. That was what the have to say. So that's the information I have, Mr. Chairman. Thank you.
Sorry, sir. Hello, sir. Yes, sir. An information also. Our origin is F40. As of today, F40 carries 3 different coordinates. 3 different coordinates. Because of the different parameters of the instrument that made use of. And as of today, I don't think it can be corrected. So you discover from such area you try to densify only from F40. somebody used coordinate A, and now use coordinate B, and now use coordinate C. You discover that they are going to have different values at the end of the day. So I think our professors that left Professor Ezebor, that's one of those things they were trying to do. We have to unify our reference system. There's a time they gave us that job, Professor JP and the rest of others, although eventually we were not, did not give us the job maybe to do. Up to today, I don't think that job was completed. So we need unification of our coordinate system in the country. I think after they will be able to maybe overcome this problem. And the vector 4 issue. Some student told me was last week or 2 weeks ago in class. Now what they do, some people just go and shout, they just shout on some things. They started discovering that people are having different body weight by shouting into that. So one of them now said, what NIS in Lagos is trying to make use of that one for is to maybe verify what the superiors are doing, whether those things are true, whether those things are correct. But those who are using it as a reference station, they are giving us a lot of problem in the state as of today. So I think this issue of taking home what we are talking about here, so that in Ogun State, in Lagos State, you're in Osun, you have a different state. The issue of vector 4, I think I'm having problem with it. So that if you can have a unified system, like NIS is trying to, Institute NIS of Oslo is trying to do, to help us to solve this problem at the end of the day.
Thank you very much. Very, very much. Yes, thank you. You can have a seat. While he's having a seat, I want to thank the presenter for this work. Because you left the work in the realm of research, the fact that you discovered that discrepancy and was not hidden, just like most people would do, just to have a good paper, is commendable. Thank you very much for that. And that's evidence of good research. Whatever the result is, let it be there. Objectivity, very, very important. And secondly, let me apologize to the first presenter. We didn't give you this much time. It's supposed to be plenary session. I hope maybe tomorrow will compensate you for that. And I hope you won't think that because Dr. Adebohemhin has affiliation with Bells University, so we gave him more time. Thank you very much. Then we also want to say this. We generally have a problem with our national spatial data infrastructure. If the Office of the Surveyor General is here and the professional bodies are here, we are supposed to, oh, beautiful, there's somebody from Moscow here. I think these are things we should take note of. I was in the last AGM, and during our plenary sessions in the AGM, it's more or less just talk about your paper and get out of here. Nobody wants to listen to the meat in the technical and the research paper people have done. And this forum is a very good forum where we can deliberate on things like this. I'm sure that this conference will have a communique, and things like this can come out from this conference, which will be a strong recommendation to the Office of the Surveyor General and, of course, the state government. So it's not overdue. We have a unified reference system. Thank you very much for that. I will be moving straight to the technical sessions. Okay. In the technical session, permit me to call on this presenter, Presenter who will choose spatial analysis of telecommunication mast, distribution and regulatory compliance of using GIS, a case study of Abeokuta North, because of some logistics. So we invite you. The paper is going to be delivered by Adewale TJ, Adewale TJ, Adekite A, and Surakat OH. Please, before you start, if you have a paper for presentation, you can please come forward here, so we'll make it quite faster. This time we have just 10 minutes for both the presentation and reactions. If you have a paper, you can just come forward here and sit down, so it can be easier for us. Thank you very much. You have the floor, sir.
My name is Olusegun, and I'm presenting the paper titled Spatial Analysis mast distribution and regulatory compliance using GIS, the case study of Adesoun North area of states. This research is to determine the spatial distribution of masts, 52 masts. All right. To assess mass coverage using multi-ring of analysis and to carry out to evaluate the compliance to the agency in charge of the enforcement of the standard.
Your hand allergic to the point.
So there are about 52 masts that were solid. We used them under GPS to do that field work. Next, this shows the population of the area. The study area information. Okay, so this is the methodology. We have the field survey using the handheld GPS. We have the GIS processing. The data acquired was processed in the GIS environment. And then we do the spatial analysis, the nearest node analysis, multi-ring, buffering analysis, and inverse distance loads interpolation. Then we check for the compliance to the standard that the agency in charge of the compliance has set, at least the NCC standards that should be about 10 meters from the road. Next. Okay, so this particular nearest node analysis shows that the masts are well distributed for proper network coverage. There is no part of Adesoun local government that is not enjoying signal strength because of proper coverage of the mast. The nearest node analysis shows that the mast are dispersed, the pattern is dispersed, and the mast are really spread apart, not randomly sighted or clustered. The mast nice coverage and minimize intermast interference. Next. So signal strength decreases with distance from the mast. Some buildings are close to the mast, like 0.5 to 1.5 kilometers. They are so close to the mast, so they are prone to be affected by the relative, the radial frequency, the frequency of the signals coming from the mast. They are prone to suffer from the signals that is coming from the mast. But those ones that are about 2 to 3 kilometers away from the mast are well sighted. Next. Okay, now this is the result of the regulatory 52 of the masts comply with the standard of the NCC, particularly regarding the road, the setback from the road. They are able to meet up with 10-meter setback. For the building, only 11 of the 52 masts are able to meet up with 10-meter setback from the building. 27 masts are less than 10 meters from residential structures, so they are not complying with the standard by the NCC. And there are 14 masts that are actually not measurable. We couldn't assess them to be able to get the information, the spatial information regarding them. Now, if you compare what we did with what has been done in Maiduguri, the road compliance in Maiduguri is 58%, but in Abeokuta North is 42%. The building compliance in Abeokuta is 21%, Abeokuta North particularly, and in Maiduguri it is 39%. Now, this is the compliance map on public health implications. Residents within 10 meters of mass basis may experience RM levels approaching IC deadline, RP, that's an international organization that sets the reference limits. The WHO classifies RF, EMF as carcinogenic, which is group 2B. 21% building setback compliance equals to 27 masts within or in safe proximity to homes. So there are about 27 masts that are close to residential buildings, which is putting those residents in health risk, health concern. In several cases, residential structures were built after the masts have been established. This encroachment shows that there is compliance nonchalant attitude. The complying agency are not doing their work because most of the buildings were built after the mast has been established. And 27%, that's 14 masts, have no measuring data. That's a regulatory measuring monitoring gap. In conclusion, the 52 masts actually covered the entire area for coverage optimization, but regulatory compliance is critically low. Only 42% meets the road setback standard, 21% meets building setback standard. This is far below comparative other Nigerian cities, particularly Maiduguri, that we compare them with. This also exposes a significant enforcement deficit with direct implication for public health. So in conclusion, we are recommending that SEC should adopt systematic nationwide GIS-based compliance mapping rules on the issue of health impact assessment. There should be mandatory pre-installation environmental health impact assessment for mass residential zones. On land use controls, municipal authorities are expected to enforce controls preventing residential encroachment on established mass buffer zones. Infrastructure relocation incentivize telecom operators to share mass structures, reducing proliferation while maintaining coverage, so that we can have a particular, we can have maybe MTN, Glo, Airtel, and other telecom service providers sharing a mass. It will reduce proliferation of mass, and then it will also reduce health hazard issues. Thank you.
Thank you very much for your paper. We will take reactions from this paper while you take your position here to attend to the reactions. Do we have reactions?
Thank you, Mr. Chairman. Thank you, the presenter. I have a few questions here. One, that is for general consumption, particularly that the accidents among us. Why center is not able to the knowledge of this network, MTN, Glo, Airtel, and all sorts of mass. So we need to have this knowledge. We talk about compliance. We don't know which of these companies are actually compliant and which is not compliant. This knowledge is very critical so that if you want to advise and if you want to sanction, you know the appropriate people to sanction and you know where we are doing well and where we are not doing well. But if you just put the whole thing together, you will not be able to come to a solution. And lastly, I have here that it would be nice to have a table showing us the summary of this result so that we want to take informed decision from there. Thank you very much.
If you match its position somewhere and you are giving a distance of 10 meters, whether to the road or to the base, and we know that the line title system in Nigeria, if the mass is located 10 meters away, belongs to another person's property. How do we now reconcile having the providers to be able to keep up with the meeting up with the regulatory body? Are we going to say that anybody should not be within a particular, maybe there should be a buffer zone? Is that possible under our land general system?
Thank you so much. Well, the first thing I would like to say is to get data, telecom data for the location of masts in Nigeria is so difficult because the telecom companies know that they are not following this standard. So, and they know that missing data means exposing their problem. So, if you write any telecom company and say, give us data for the mass location, you are not going to get it. That's the truth. You can make attempts. We tried it. We deliberately talk about all of these things. And we already saw that we can't get that data. So we acquired data already for the field. The next challenge is that we don't know which telecom provider is the owner of a particular mast. Because they do not write the name of the provider there. So we just acquire those the coordinates of those data and then we come to process them in the GCFR audit. Those are part of the challenges of this research. Then we talked about the buffer zone and all of that. Many of the buildings were built after the mast has been established. Ordinarily, the mentality of an average Nigerian is that you don't want to even leave the setback of the road. How much more setback for the mast? People don't even understand the data application. And even if they know, they feel that this is not really like threatening, that they should, observe that buffer zone. And average Nigerian is not aware of the 10-meter buffer zone that is the standard that should be observed, the setback. They are not aware. Okay.
The point I'm making is the mass is already there.
Yes.
The adjacent land belongs to, when the mass is being built, it's somebody's property. They negotiated with somebody and they put it there. The adjoining land belongs to somebody entirely.
Yes.
You are now asking, now this person must keep the 10 meter or whatever distance. He has his own property, he has his own. What I'm saying is that it will not be a condition as part of the solution or recommendation that once a mass is here, any building, any property within that zone should be acquired by those people putting on the mass. So it will be making to be able to comply with that.
They can see the problem of the...
Okay, thank you very much. So you don't give permission, sir. You are forgiven. But just to clarify this point, please let's be cautious of our time. Just go straight. Okay, finish up. I wanted to add on something. I think it should be part of your invitation to this project. So when you are you just specify another definition.
I was actually saying that the compliance agency that is supposed to enforce these things are not even doing their work. So if there is one that enforce the national law, everyone will be doing whatever. So that also is a major discomfort to do research.
Okay. Do you have any other? I think I was going to add to that after specifying the limitation, which is ability to identify individual network providers, that is one. Then the issue of your choice of GPS instead of any other instrument is really addressed that. Though I know that the area covered by telecommunication masts, give or take, may be within the range of 1 to 5 meters. In some cases, even more than that. They acquire such space, and then your random GPS has an accuracy of plus or minus 0 to 3 meters, in which case your random GPS can effectively take care of that. And besides, if you are having some very sensitive infrastructure, getting your computer station and mounting and setting up becoming very obvious, it will attract a lot of issues. So the speed at which you carry out projects may be affected. So the random GPS is just okay, given the accuracy. Should we talk about how our country has problems with location and allocation? We just wake up and then allocate it out. Should we blame the partners? Should we blame the government? Should we blame the surveyors? I don't know. It's for us to answer. But I think the project on this paper is well understood, and I think we can take it up from here from the recommendations. Let's give a round of applause and thank you. We'll move to the next presenter, which is right here before us, automated Obasanjo. Sorry. Predicting elevation using multi-linear regression and GNSS data. We have the authors Omogunloye, G.O. A.O. Sabani, T.J. G.O. Akintoye, S.O. Olugbemiro, S.O. Adebohemhin, F.I. Adeyemi, A.V. Olakunle, A.S. And to present its Surveyor A.O. You have minutes, but because as the timekeeper before, we'll give you extra 2 minutes as we ready. Thank you.
Thank you, sir. Good evening, everyone. All protocol are well and duly observed. Presenting a topic that says predicting elevations using multiple linear regression and GNSS data. Please, next slide. So, regression analysis is a statistical technique that is used for analyzing data and predicting or estimating a quantity. Quantity can be temperature, can be market trend, can be any quantity we can think of. Our focus here is elevation using multiple linear regression model. When it comes to multiple linear regression model, we have 2 or more independent variables and 1 dependent variable. And what do we want to do? We want to establish a relationship between these variables, that is the 2 independent variables or more, and 1 dependent variable, as far as multiple linear regression is concerned. Authors or researchers like Adebohemhin et al. Look at accuracy assessments of elevation obtained from SRTM using various interpolated comparison with GNSS data, and other authors have looked into various statistical techniques in estimating elevation. However, these studies applies multiple linear regression to estimate elevation at using GNS data, the northern eastern continents. So the aim is to improve elevation prediction for geospatial applications. We've seen that we have different global data sets where you can extract or obtain your elevation data. The question is how reliable or how accurate these elevation data, since they are global and you are in your local region, using years, using GNS equipment to obtain your elevation, and you felt that there's no need to go to site. Since I have these global data sets, I can extract. So that's some of the essence of using these methods to enhance the elevation data you obtain from your global data set. Please, next slide. Study area is Gansaka Road in Ilorin. Tassos hostiles with GNSS was used to obtain the eastern, northeast, and heights coordinates. We have 423 observations. Next slide. So the methodology on the study area, we use GNS data, we collect our data using Tassos, GNSS equipment, then data processing, then we did descriptive statistics, then from there multilinear regression and elevation prediction. Before we could deploy our multilinear regression model, we subject our data we obtain from GNSS equipment to descriptive statistical method, in order to know if we can deploy multiple linear regression models for the data. So we computed for mean, variance, standard deviation, skewness, kurtosis, and at the end of the day, we did regression coefficients. All of this is to enable us to know, like the mean, median, and standard deviation. Those are the we want to know the central essence and tendencies of your data. How spread your data in relation to the mean value. These are the details of our descriptive statistics. Data set contains 423 observations. Elevation varies moderately. Distribution suitable for regression modeling. Next slide, please. So this is our regression model. As you can see, H equals to beta naught plus beta 1 multiplied by the northern coordinate plus beta 2 multiplied by the eastern coordinate plus the error. The beta naught to beta 2, those are the coefficients. The beta naught is the intercept, and it represents what will be the value of this beta when all the predictable variables are equal to 0. What are the predictable variables? The northern and the eastern coordinates. And so how are they influencing our elevation, which is the height? So for that equation 1, we can generally model this multiple linear regression into this general equation y equals to ax plus e. So we took this general equation as a least square using projection theorem concepts. That is y stands for our observation. Then our observation can be decomposed into two parts, the signal and the error. The signal has the component of A and X. What is A? A is a design matrix which is obtained from our observation equation. will give you what you have in equation 4. The x is the parameter we are computing the coefficients that will make us to define our multiple linear regression model. Then the E is a component of our residual. Then from there, we are able to apply our projection theorem to have our equation 9. I'm very sure we are familiar with that equation. A transpose A inverse A T Y. So that will enable us to compute our x value. Regression model results from that equation. We are able to obtain our coefficients beta naught 21 327.93. Then the beta 1 is 0.00135 and beta 2 minus 0.03346. And we carry out regression statistics to determine how accurate our model is. We realize that there is a significant correlation between the indicator variables and the height or elevation. Then we look at the model performance. We plot our x coordinates with respect to the computed, the predicted heights and the observed heights, and we can see that they are in alignment. We plot them against their x and y coordinates. Now, the interpretation is a strong agreement with our results. So, conclusion: multiple linear regression effectively predicts elevation. Nothing and listing are significant predictors. Model achieve high predictive accuracy, R squared 93.36%. So we have a significant value. The recommendation, we can validate using independent data sets, include carrying and land use variables. There are some other variables that can influence prediction or estimating of elevation, such as those variables can be incorporated to enhance the model, apply advanced spatial analysis, improve data quality. Thank you.
Thank you very much. A very mathematically presented paper. It's highly mathematical, and I saw Professor Aremu just nodding his head that is easy. Now, do we have reactions and questions from his presentation? Okay. And let me say, I really commend the robustness of our interrogation. Every paper generates interactions, interest, and that is very commendable.
Thank you, sir. Once again, the presenter, congratulations for the work done. I have really two points here. One, I know that many methods out there, and nowadays now that we're talking about machine learning model, which were used instead of linear regression. But the authors are using multiple linear regression to do this. So, but just enough for the choice of multiple linear regression is not known. So I think you should take that one in the paper. I think it's there. Number two, validation also is a key area when we are doing work like this, and there are many methods we can use in our validation. While we have stated standardization and what have you, but there are fundamental things that I think we need to do. For example, the point you are predicting, the elevation you want to predict, because what this work is trying to help us to accomplish. For example, if I don't have high data in some point, and I have this model, I should be able to use the model to generate height in that area. However, for me to rely on the output of this model, I need to be sure I know the confidence level attached to this work. That has not not been shown. The level of what's it called, reliability, which I can place on it, is not known. That's number one. Number two, how you carry out the validation itself is also not clear. For example, did you do maybe an 80-20 data splitting to check what to have, or did you do 70-30, or what did you reserve maybe a year of observation or data for a certain part of your study area, and you now use other parts to predict for that case and not compare the results. So we need to know the method you use in carrying out your validation before we now talk about prediction and prediction results. So these are the things I think you need to make clear in your work, particularly that it's because of our time, I want to present it. Thank you very much.
So, as for the justification of the multiple linear regression,
Thank you very much for the presentation. I just want to, like Dr. listed, why you use this your method. Like for instance, if you use ONS and GNS, you are trying to make use of covariance matrix. Then you discover that you are thinking of weighted observations. So in that case, you may minimize your error more than what your ONS is trying to make use of. You compare this method with another method before you finalize and said this method is very good for this work. So, for instance, if you make use of this and GLS, you might perhaps, I don't know, maybe you can answer that, you might perhaps get a better method by which you can have a better result more than using this method. I'm very concerned about just staying on this without looking at other methods in comparison with this.
okay, sir. If I may start from him, we have not actually validated the model outside the observation data we use from the presentation. What we use, if you can see the graphical illustration of the performance, we use the data obtained from GNSS to test the model. That's why I showed the observed arts and the detected and predicted arts in comparison with each other. So we have not actually used data beyond the study area to validate this model. So we see the work in progress. Then coming to Dr. Ayodele, the justification of multiple linear regression, the usage, there are some locations that you can actually deploy multiple linear regression. Areas that are not actually undulating, a very high hill, very slopy area, multilinear regression model can work perfectly well. So that's one of the reasons why we deploy that. And in using our GNS observed data, in comparison with the predicted parts, we see that it's giving us accurate results. We will see that the spatial coordinates, the eastern and northern, are actually influencing the elevation in that study area. So I don't know if I've answered the questions.
Okay. Well, thank you very much. Some of the issues raised are issues you want to go back and work on to improve on the quality of the paper, because I'm sure if you don't have a book of abstract for this, you can still tidy up the work
northern and the eastern coordinates. There are other variables that are influencing elevation.
Can you be commenting that for further research or since by another person or you can still add it to your
Still add it.
Okay. If that is what you are considering, you can also equally do that. Thank you very much for your paper. Let's appreciate it again. Thank you very, very much. We are going to have a paper from an online presenter. I don't know if our network can permit us to do that. Unfortunately, the gentleman that presented about network for America has gone. If he was here, he would have helped us with network. So we can get our president.